All right, so I didn't work on the math today. I'm almost done with it, but the math is for the galaxies, how to calculate the galaxies, and because there's a big time problem going on. There's all kinds of fluid dynamics going on and gravitational things that people don't understand. When you realize how the electromagnetic field slips into it, and the magnetics and all that stuff, how it all works together, it's pretty simple. Not mathematically, it gets a little bit complex, but I put that down today because I got thinking about magnets and stuff like that, because it's all electromagnetic field, so I'm going to study magnets. And I was watching this chemist, and it kind of blew my mind when I saw this one little thing he did, which I've seen similar things before, didn't think much of it at the time, but because I was thinking about how to structure atoms, I saw him basically put two atoms together and drop the shell level, and how it all just flew together, and I went, son of a... So, one of the big things you got to learn is that there's no such thing as a monopole magnet. I'm thinking toroidal magnets, but I got square ones and stuff like that coming in right now, but I got to get a hold of some toroidal ones. I can't even say it right. The nucleus, it's magnets. It's just magnets. And what you call the electron shell is magnetic shell. It's magnetic fields, based on how the protons were put together. Protons are basically just magnets, and so what you guys consider a neutron, a neutron is two magnets facing each other, so they kind of neutralize something themselves, and there's actually nothing really there. There's magnetic fields is what you're playing with, and that's why you need magnets at one end of a wire to control the magnets at the other end of a wire. And the electric current you're moving is the magnetic field. It follows the wires because it's an easier path. And the electrons aren't actually electrons. That's there's a couple of particles. I'm pretty sure they're neutrinos and antineutrinos. One likes to be in the field, and the other one just kind of passes through. That's your quasi-particles, or whatever you want to call them. Your zero-point energy, stuff like that. What you got going on is particles that pop in and out. They're literally passing in through and out of your magnetic fields and all that, your light waves and all that. They're not, those are the ones that just kind of like don't do a lot. Then you got other ones that get into a, like an electron, like magnetic field, and it loves to hang out there. And it kind of looks like an electron. That's what we call an electron, but really it's not. And that's why, well, when we look at an atom, there's a bunch of those actually, and or sometimes there's not any, and that's your like a hydrogen, your positive charge hydrogen. It doesn't have any of those particles stuck to it yet, and but they're not actually the energy. They're not even really part of any of it. What they do is they block it. They become the thing that stops the other magnetic shells from appearing. It blocks it out, neutralizes it, basically, covers it. Think of iron fillings surrounding a magnet. Anyways, I got magnets on the way. I'm going to have a whole lot of fun. I will get back to that math. But right now I am studying magnets. Oh my. All right, peace.